In this video, what we're going to do is we're going to continue our work on differentiation, and we're going to expand what we know from a basic introduction of it to working with negative powers and roots. Now, when we are looking to take the derivative of something at this stage, we always want it written in the same form. We always want it written in the form ax to the power of n, something like that. And if it's several terms, we want them written as separate terms, all in this form. Now, this will come in a different video where we look at when we've got multiple terms. However, for the moment, what we're going to focus on in this video is when we've got negative powers and roots, and when we're dealing with those, how we have to deal with them and what we work with. But to do this and to start, what we're going to do is we're actually going to recap some of the important rules that we looked at in National 5 when working with powers and indices. So we're actually going to refresh our memory of 4 key indice laws that we worked with at National 5 and how we can write these such that they're in this form already. Now, whenever we had something that was written as 1 over x to the n, so 1 over x to a power, 1 over x squared, 1 over x cubed, anything like that, we were able to write that as x to the power of something. And to do that, we just made the power negative, so we had x to the power of negative n. If we had the square root of x, we were able to write that in the same sort of form as well, so as an x to the n. But in this case, with the square root of x, it was x to the power of a half. If we then expanded x to the power of a half to be the nth root, so cube root, fourth root, fifth root, etc., instead of to the power of a half, we actually would take to the power of 1 over n. So whatever the root we were taking, so if it was a third root, it would be x to the power of 1 over 3. Fourth root, x to the power of 1 over 4. 100th root would be x to the power of 1 over 100. We have to look at that and decide. And this last one could be the nth root of something to the power of m. Or, remember, that could be written as the nth root of x, all to the power of m, like this in the bracket. It could come in either of these two variations, either of these two forms. When we get something like that, it's kind of a combination of a couple of the indice laws, because we end up with x to the power of m over n. Now, these 4 rules, these 4 indice laws are key. We have to write something as a set of terms in this form to be able to calculate the derivative. So we're going to look at a couple of examples of these sorts of ones, so dealing with negative indices and roots in this video, and we'll look at what happens when we've got more than one term in the follow-up video to this. So let's look at an example. Imagine I have something that I want to say to you, y equals square root of x, and I want to find the derivative of this. Well, the first thing we have to do, and bear this in mind, is we have to write whatever we're after differentiating as ax to the n. Now, there's no a, there's no constant in this, so great, don't need to worry about that. But square root of x, remember, can be written as x to the half. So now that we've got it written in this form, we're able to take the derivative. So I'm able to calculate, in this case, dy by dx. And it follows the exact same pattern. Remember to get the derivative, bring the power down in front, and take one off the power. So in this case, I'd bring the power down, so I've got a half, then it's multiplied by x, a half take away 1 gives me negative a half. So that would give me 1 half times x to the negative a half. So that would be the derivative of x to the half there. We're able to do it that way. We have to remember to do this first and change it into this form. So another example, again, we'll maybe look at another root example. Let's imagine I want to find the fourth root of x to the power of 9. So something along these lines, fourth root of x to the power of 9. Well, again, we have to write it in this form. So x to the power of something, ax to the power of something. Again, no constant, no coefficient here. Great, so it's just going to be x to a power. This one here, remember, was the nth root of x to the m. Well, that was x to the power of m over n. And in this case, putting the numbers in place, that'd be x to the power of 9 over 4. Now that we've written it in this form, I'm able to do f dashed of x. So again, same format. Bring the power down in front, reduce the power by 1. So bring the power down in front, I've got 9 over 4 times x, and then if I take 1 off of there, I get to the power of 5 over 4. Excellent. Job done. When working with roots, it's quite straightforward. It doesn't get much more complex when we're working with negative powers either. imagine I had something that was written along lines of f of x equals 1 over x to the power of 7. Again, we always want to write it as ax to the n. We always want to write it as something like that. So 1 over x to the 7, remember, that can be written as x to the negative power. So in this case, that becomes x to the negative 7. Now that I have it written in this form, there's no coefficient there, we then just go for it. So we then just do our derivative. And again, same idea. Bring the power down, reduce the power by 1. So bring the power down, we get negative 7x. Reduce the power by 1. Now watch it with the negative numbers. Remember, if you reduce this by 1, this doesn't go to negative 6, it goes the other way. So we get negative 8. So negative 7x to the negative 8 is what we end up getting there. Okay. Now, ones like this can be fairly straightforward. We can introduce coefficients to this. They don't up the complexity too much. We just got to watch one or two little tricks that come into play. So let's imagine I have f of x equals, let's say 2 over x to the power of 4. 2 over x to the power of 4. Now again, I want it written in this form, ax to the n. And this is where you have to watch. If we've got a coefficient on the top, and I've got this, that becomes 2x to the negative 4. Think of when we've got something like this, a over x to the n. That's the equivalent of saying a over 1 times 1 over x to the n. Now this part here can become x to the negative n, which means the whole thing becomes a times x to the negative n. You've got to be wary though if this changes. So if we had, let's say, 1 over a x to the n, that would be the equivalent of 1 over a times 1 over x to the n. And this x to the n follows this rule again, but in this case it would be 1 over a x to the negative n. So watch this bit here. Watch these little tricks. And that's what we've done here. This is of this first form and this one, so it's 2 times x to the negative 4. Now we simply do the derivative of what we're after. So coefficient in front 2 stays the same. Bring the power down, so negative 4x, and then reduce it by 1 to the negative 5. We then simplify the numbers in front. 2 times negative 4 gives me negative 8x to the negative 5. Now, look at an example of this form here. Let's imagine I've got, and I'll go to y notation this time, y equals 1 over 4x to the 12. Let's imagine I've got one like that. Now, following this form here, 1 over ax to the n, work it through, we get 1 over a times x to the negative n. We use that to simplify this. So in this case, I end up with a quarter. I keep the 1 over 4, and then it becomes x to the negative 12 there. Once I've done that, it's in the right form. It's in this ax to the n form that I want here. So it's now just a case of working it through and calculating the derivative. So doing that, we just follow the exact same rule we've always followed. So dy by dx equals, write the coefficient in front, so a quarter, times, bring the power down, negative 12, x, and then reduce the power by 1 to the negative 13. So we've then got a quarter times negative 12, so that gives me negative 3, x to the negative 13. Using these laws, we're able to do it for any negative power or any power with a root. It's still the same technique, and it's still the same rule we follow. The only difference is that initial step of sorting things so that they're in the correct format. But we just use the endless laws we learned at National 5 to be able to do this and to be able to modify them.